We are going to talk curve sketching today, or more specifically, I'm going to be um, sketching the curves, and you're going to follow, and this is going to be instructive, and I fully expect you to do these problems. It's not just for funsies, okay? I actually started recording or lecturing before recording, so okay, it's okay though. First thing we're going to do is start here. We're going to find this is kind of ugly. I'm going to write this as 1/12 x to the third plus 1/12 x squared. And I'm going to factor out the 1/12 and two of the x's from each of these guys to have it in factored form because it's nice. Okay. Off rip, when we have factored form, we get our x-intercepts as 0, 0 and -1, 0. Uh, if you can't see it off rip, please work it out. Then we're going to derive it. It's pretty straightforward. And then you get this. I'm going to try to factor it. It's not the nicest thing to factor, but it's okay. I ended up multiplying everything by 12 on the outside or on the inside. So like 12 over 4, 12 over 6, and then divided by 12 on the outside like that. Because I want to transform the function without actually modifying its behavior. Right, so you end up with something like this, which means you can factor out x's out of both of them. You get something like this, and you should get critical values at 0 and -2/3. And we will figure out what the y values, not the y value of the derivative, the y value of the function after. Okay? We put it into a sign chart, right? We plug in like, oh, -10, that's a positive. We plug in, I think it shows like -1/3 or something like that. It's gonna be negative. And then I plugged in like +10, got a positive number. Okay. And so our max is -2/3, comma, and then unfortunately, we're gonna have to plug in -2/3 back into here. Okay, but that's okay. Because if you do that, you get 1/12. And I actually recommend it in factored form over this, and I'll show you why in a second. -2/3, it seems to do weird addition, squared times -1/2/3 plus 1. And that's the same as 1/12 times 4/9 times 1/3. Ah, and that means we have 4 over 12 times 9 times 3. But aha, 4 over 4 times 3 times 9 times 3. Ah ha ha. And that gives you 1 over 3 times 3 is 9. 9 times 9 is 81. Ain't it beautiful? And that's how we get this as our local max. We'll do the same for our local min by plugging it back into the original function. The min is going to equal 0, comma 0, because that also happens to be our intercept, but that's okay. All right, easy money, right? So then what we're going to do now is we're going to, the heck? What we're going to do now is we're going to solve for y double prime and all the concavity behavior, okay? Okay, so in order to do concavity, you do in fact need the first derivative. So we'll have this to work off of. Um, I'm gonna like squeeze it in here, but then once we delete it, it'll work out really nicely. Actually, not whatever. So once we have this, you can say y double prime is equal to 6 over 12 x plus 2 over 12, which is going to equal 1/2 x plus 1/6. Okay, I'm going to shimmy that up so we have some space to work. Just like that. Oh, that is ugly. There we go. Right, which means we have, for our point of inflection, is y double prime equals 0. So then we'll have 1/2 x plus 1/6 equals 0 because that's y double prime. and it's going to be 1/2 x is equal to negative 1/6. I'm going to multiply both sides by 2. X is equal to negative 1/3. Yeah. Okay. We're going to put that guy into a little sign chart. And that's going to be negative 1/3 lives here. Choose a very negative number, and that will give you a negative number. Choose a very positive number, that gets you a positive number. So that means we know this is concave down, and this is concave up. Yay! Right? And we're gonna put it all together. Okay? So what we're gonna do now is we're going to extract all of the important parts. Okay? So for this, the important part is not that. For this, the important part is pink right there and that. We no longer need this. Whoop. Okay. What we're going to do now is we're going to put it on a big old sign chart and collect all of our data in a graph. It's going to be great. Okay, we'll start with the critical values. So you're going to have like negative 2/3, and have like 0, and then for your point of inflection, you have like negative 1/3, right? Okay. Then what you're going to do is you're going to say, oh yeah, this section is increasing, and draw it more or less however you like in terms of like marking up your work. And this section is ugly, it's decreasing. Okay. Similarly, you know that the section not including here, okay, friends, not including here, is concave down, and this section is concave up. Easy money, right? And then what you're gonna do, you're gonna take this and those and the maxes and draw the graph. We're actually gonna turn this guy sideways so we have some more space. Let's put in the important values first. We have a max. Actually, let's put these guys in. So we have, let's say, negative 2/3, 0. Oh, actually, let's put negative 2/3 right here. Negative 2/3, 0. Right? Cool. And then we're going to put in our point of inflection, which is negative 1/3, right there. Right? And then we're going to put in our maxes. So we have a max at y equals 1/81, which is really small. But for the sake of zooming in, I'm going to put it right here, okay? And we have our min at 0, 0. Okay, now we can in good faith start graphing, okay? I'll do the graph in like this really ugly orange, okay? So our max is negative 2/3, comma 1/81. So that is right here. I'm gonna label that. Great. We have our min right here. It's gonna be our min, our max. Right. Okay. Nothing crazy yet. Now we're going to go in, start mapping out this. Okay? From negative infinity all the way to negative 2/3, you're concave down, increasing. Let's revisit what that looks like. Okay? This is concave up, or sorry, this is concave down, right? This is concave down, increasing, and concave down, decreasing. Okay? Similarly, this is concave up, this is concave up, decreasing, this is concave up, increasing. And up to here, oops, and up to here, we are concave down, increasing, which is concave down, increasing. Okay, you can do that. That's attainable, right? You're just gonna, that's it, easy. And then right here, we're going to be concave down, so somewhere on here, decreasing, like that. Okay. Oh shit, got something important. Forgot, forgot one of our zeros. That's okay, because this right here just so happens to be -1, comma, 0. Easy, right? This is going to be your first x-intercept. Okay. And then your second x-intercept is over here. So we already have that in. We'll deal with it later, right? Okay. Now, where were we? -2 to -1/3 is right here. And we are concave down, decreasing, which looks like that. That easy enough. Yeah, that's it. That's it. Concave down, decreasing. Do we hit 0? No. So don't do that. You can also graph it like this if you like, or like that. Just like a nice little slope, right? How you do it, I don't care that much. Okay? If you'd like, you're welcome to mark it as the point of inflection, right? In fact, I recommend you do. And then, and you can get the y value too if you want. I don't mind. And then we'll have from -1/3 to 0 is concave up decreasing. Concave up decreasing looks like this. So then we're going to taper out a little bit, right? Kind of whoop like that. If you really want to smoothen it out, you can kind of go like that. There we go. Not quite as smooth as I like, but it's fine. There we go. Right? And you definitely do want to hit that. Okay. And then from um 0 to infinity, your concave up increasing. And you can just kind of just like that. Ta-da! I don't know what to tell y'all. It really is that easy.